content is there. So as an introduction, you know that there are long-term plans for human habitation of outer space and deep space. For this to happen, several elements have to be developed in order to be able to thrive. We see that there is a key element that has to be developed, and it's related to the human factors and to understand how humans perform in space. So a key element for that is how the habitat is designed. What tools do we have? Architecture, in conjunction, obviously, with all the technical elements that are presented. So this was our first approach to it, like how would we use this tool? And I'm sure at some point in your life, all, if not all, most of you have had the experience of having a great day or a bad day because of an architectural feature. And it's, for example, arriving to your hotel, opening the window and see that there is a wall in front of you. So architecture can help to make your life better. So the other thing is that this is our first approach, and this project was born as a cafeteria conversation, an interdisciplinary cafeteria conversation with some colleague of mine who's an architect and a mechanical engineer. We also had the input from a space physiologist in Colombia. She works with she's a captain in the Colombian Air Force. And also we had the input of geologists and biologists that have expertise in astrobiology and can tell us a little bit about their work. The other aspect is that we're currently developing some analog programs that we intend to make. We're developing this analog spacesuit simulator that we tested in the MDRS in Crew 187. It's nice to see you again, guys. So we also built this analog dome for crops development in our university in Colombia. So what was the architectural approach from the architect? We started discussing a lot of things. We actually started discussing about how would a city on Mars look like. Then we started downgrading the conversation and we said, hey, we can make a proposal on how we're going to inhabit Mars eventually. We made a proposal based on this architectural approach for a habitat for not an early stage of exploration, but on a colonization process when we are exploring other areas of Mars, of the planet Mars. So we made a proposal for a habitat for a crew of 6 to 10 people based on these premises. First, the concept our architect used was the concept of dwelling as an architectural approach. It's based on the fact that it's not enough just being there, but making the space yours, like being able to properly tell that this space is yours. Based on things that we've read and things what we heard about comments in deep space habitation and lower orbit habitation, there was this sensation of confinement that was one of the most hard feelings. And having been also in an analog mission, it's important to say that that sensation of being inside all the time can be hard. So the idea was to design something that felt like coming from inside to outside. Design the habitat to be able to make appropriation of spaces in different aspects, like in professional and in personal aspects. Also for security and safety reasons, and also for psychological reasons, we want spaces to be easily isolatable. Since we are making a habitat that we want to develop for further exploration, we want flexible configurations or flexible, let's say, configurability that allows us to make different missions with the same core structure. And finally, we have developed it in such a way that the main core will house the structure and the services. So this is a first approach. This is actually a render image of how the room of the habitat would look like. This feature, this feature in the window, it's thought to be able to, for the astronaut to be able to embrace it and to use it as he wants to, for reading, for leisure time, for any activity that he would like to perform there. So this is the main core. So this structure here is the main core that we're going to see a little bit better in the next. We made it thinking about launching the core itself. So this fits inside the payload bay of heavy lift rockets that are available today. So since we are making this for a future exploration, we would say that this technology would be available. And the outer structure, like the floors and the walls, will be built by some technologies that we have the fortune to see today, and I have personally been able to work a little bit on its 3D printing of in situ resource materials, and with a deployable structure of that would be filled with water for a radiation protection. I had to admit that at this point that we have overseen some of the technical details, but that's on purpose because we wanted it to be an architectural approach for it. So this is a more detailed view of the habitat. We have like 3 levels, the ground floor, the first and the second. We have within these housing spaces that would be the place where the crew would perform their activities related to mostly living their lives. We have the services that will be in the core, and the first floor will be dedicated for laboratories and actually working space. More detailed, here we have like the ground floor planning, where we have laboratories on this side. We have the control center on the inside for security reasons, and we have these working spaces that this allows us, and we're going to see this more clearly, to have an inside, and then we walk towards more open spaces and outside, and then more outside. So this would, we intended to be as a tool for helping this psychological issue that can arise from confinement and isolation. This is the second floor, where each of the crew members would be able to have their own crew quarters that we've heard from people that this is important, and we have lived it, and being in an analog mission, it's important to have your own place where you can stay, where you can be yourself and maybe not interact all the time with the crew. We have also a kitchen. We found out that cooking is a very, very rewarding experience, and eating a good food is a rewarding experience during this type of exercise. Finally, in the second floor, we would have these places that we developed that would be immersive, interactive rooms that would allow us, via technology that is already developed, like gaming platforms, like omnidirectional bands and like immersive virtual reality technologies, would allow us to be able to recreate to some extent some environments on Earth. Whether you want to be in the middle of a city, you want to be in the middle of a forest, you can approach that, and that would be easier for you to kind of lessen the experience of being away from Earth. So this is a short video that I would like to show you regarding how does the going from inside to the outside would look like. Since you're in a narrow, so you go to the outside, and then you go to the outside, it would feel like you're not confined, but you have different possibilities. So the next step is to make it into an analog station. Currently there are no analog stations in South America, although there are places, and we've written a paper on this, that would allow for a very good simulation of, in some places like some deserts in South America and some mountains, where we would simulate human factors, mission designs, mission operations, EVAs, how the habitat would impact humans, and more importantly, in a more like a political view, it would be easier for Latin American crews to access this kind of experiences and technologies. So we run the numbers. A base this size, that is roughly 10 meters tall and 20 meters in diameter, would be costs between $250,000 to $370,000 to build, which is kind of a lot of money, but it's not that much. It is doable. The operation in Latin America, it's actually cheap. It's really cheap because of energy and water being resources that can be used. And so it is a doable project. These numbers show us that it's a doable project. Of course, we would have to run in a lot of more details. So as a conclusion, I'd like to say that one of the most important things that came from this is that a methodology and a language was proposed. So maybe the proposal, the habitat, it was not the best habitat, but it was like a first iteration, and it came from a methodology and an architectural design, an architectural language that can be implemented further. So we also did an estimation for it as an analog base and showed that this was doable. And we made interdisciplinary work, which is key for this type of work, with inputs, as I mentioned, from different types of people, with different views. Even we had, at the beginning, issues with language, because architects use some words that engineers use them for something else. So we achieved to increase our knowledge on the topic of space exploration and to put this topic on the table so we would be able to discuss it further, which we consider it's a gain on itself. We generated this interdisciplinary work. We were able to get to people that would be interested in funding this kind of development. And finally, we generated this interest in some of the parties, like the Colombian Air Force and some private companies, to develop this analog station further in Colombia. So thank you so much. It was, I think, on time. So thank you so much, and I'll be more than happy to take your questions if you have time, or if you don't, please after the session we can.
We have time for questions.